question, what is the capacitance? One example. What is the capacitance of the arrangement? Of four plates of plate area A. A is plate area at a distance D. In air medium. In air. Okay. So this is the given arrangement. Is plus, this is minus. Okay. The separation is D. What about this separation? D. This separation also D. Okay, this is a diagram. What is the capacitance of the arrangement of four plates of area A at a distance D in the air? This is the first plate, the other one second plate, third plate, this is a fourth plate. Four plates. What is the effective capacitance? C effective. This is the question. C effective. This is the question. Okay. How to get it? The two plates 1 and 4 are connected with the positive terminal of a battery. We can show now like this. Positive end, the other one is negative end. Understood? This is a positive end, this is a negative end. So the plates 1 and 2 are connected together with the positive end of the cell or battery. The plates second and third plates together connected with the negative terminal of the same cell or battery. And we have to assume like this, otherwise we cannot solve. And because of this arrangement, we understood, and plate 1 shows no positive charge, and plate 2 so negative charge, and plate 3 negative charge, and plate 4 positive charge. This is positive. Remember student, between 1 and 2 electric field downward direction, between 2 and 3 electric field between 3 and 4 electric field upward direction. Okay, understood? So between the plates 1 and 2 form a capacitor C1. Plates 1 comma 2 form a parallel plate capacitor. And let it be C1. Let it be C1, correct? Then what is C1 value? And plate area, all the four plate area same separation D and filled with air medium in dielectric constant of air medium 1 not A by D. Am I correct? What is C1? Epsilon not A by D. Then plates 3 comma 4 form another parallel plates capacitor. Let it be C2. Epsilon naught A by D. Epsilon naught A by D. Seeing the polarity plus minus, again minus, not plus, correct? Plus minus, minus plus means the two capacitors, because of the polarity shown in this figure, the two capacitors are in parallel combination. Here C1 comma C2 are in parallel combination. Why parallel combination? Positive plates of two capacitors connected together, negative plates of these two capacitors connected together means this is positive combination, that is parallel combination. For parallel combination, what is effective capacitance? Just arithmetic total, that is algebraic sum C1 and C2. So 2 epsilon naught A by D. This is the final answer and copy it. So we will discuss one more similar question. I hope you all understood the concept. I move it to next question. Example 2. What is the capacitance? Question. What is the capacitance of arrangement of four plates of area A at a distance D in air medium. The given arrangement four plates are given. These two are connected together. The other two are connected together. Okay. This is positive terminal. This is connected to negative terminal. The plates number 1 is 2, 3, 4. And question, what is the effective capacitance? Find the effective or equivalent capacitance. Capacitor. So dear student, what is each separation D? Each separation D. Okay. Four plates. If we look at the polarity, the plate 1 is positive, plate 2 negative, plate 3 positive, and plate 4 negative. Okay. So looking the polarity plus minus, then minus plus, then plus minus. Okay, plus minus and minus plus and plus minus. The polarity changes alternately. Polarity changes alternately. So this give the capacitors connecting 1 comma 2, capacitors connecting 1 comma 2, the capacitor connecting 2 comma 3, the capacitor connecting 3 comma 4, or in series combination. Am I correct? The previous one parallel combination. Here all the three are in series combination. Series combination. And all the three are identically equal because in all the three same plate area, same separation, same insulating medium filled the gap between the plates. This is air medium. So C1, this is taken as C1, the other one is C2, the other one is C3. All the three will be equal. C1 equal to C2 equal to C3 equal to epsilon naught A by D. Here's a dielectric constant of air medium 1, K equal to 1. And all the three in series combination mean 1 by C must be equal to 1 by C1 plus 1 by C2 plus 1 by C3. This implies 1 by C equal to C1, C2, C3 equal mean and 3 by C1 or 3 by C2 or 3 by C3. Why? C1 equal to C2 equal to C3. And this implies what is effective capacitance, either C1 by 3 or C2 by 3 or C3 by 3. and therefore the effective capacitance epsilon naught A by 3D, epsilon naught A 3D. So this is the answer, 1 by uh, 1 by C1, yeah, as C1 by 3, C equal to C1 by 3, or C equal to C2 by 3, or C equal to C3 by 3, C1 or C2 or C3 equal to epsilon naught A by D. So this is the answer, and copy it.
Sir, I have a doubt, sir.
So, yeah, dear student, here what we have discussed series, but this is not actually series. Why? Because, and look at the first capacitor. First capacitor na plate 1 and plate 2. The first capacitor உடைய positive terminal A ஓட connect ஆயிருக்கு. Okay, A. Second capacitor ஓட positive terminal A ஓட connect ஆயிருக்கு. Third capacitor between 3, 4 அதோட positive terminal A ஓட connect ஆயிருக்கு. First capacitor negative terminal B ஓட connect ஆயிருக்கு. Second capacitor negative terminal B ஓட connect ஆயிருக்கு. And third capacitor negative terminal B ஓட connect ஆயிருக்கு. So 3 capacitors C1, C2, C3 with equal capacitance epsilon naught A by D. In all the 3 capacitors are connected between the 2 end A and B. 2 end A and B. Then what is the meaning? Potential difference between uh, 1 and 2 and 2 and 3, 3 comma 4 are equal. Equal potential difference. Equal potential difference, and all positive plates connected together, all negative plates connected together mean resistor this point strongly. The combination is parallel combination. Make note of it. The capacitors C1, C2 and C3 are in parallel combination. Parallel combination. Therefore, the effective capacitance, just algebraic sum, C1 plus C2 plus C3, then C1, C2, C3, all the three equal to epsilon naught A by D mean what is effective and capacitance? 3 times epsilon naught A by D. Another example, a capacitor is made of and flat plate of area A is made of a flat plate of area A and a second plate having a stair like structure as shown in the figure. the width of each stair is A, and the height of each stair is B, and find the capacitance of the assembly. Okay, this arrangement is a straight plate. The next one is 1, 2, 3, this other one 4. Okay, and this separation B is another B. What about this separation 2B, and third separation 3B? This A, A. Okay, A. Then the total area, the fourth plate A equal to 3 times A, and filled with the air medium. Yes, nothing is mentioned. Air is the plates, between the plates. Listen to me. Now we can separate into three capacitor. The plate area A separation B is taken as C1. The plate area A separation 2B is taken as C2. The separation 3B plate area A is taken as C3. Okay. The lower plate is connected to and positive terminal of a battery. The upper plate is connected to negative terminal of the same battery. Negative terminal of same battery. And here there are three capacitor. All the three capacitor positive plates are connected together. All the three capacitor negative plates are connected together. So in this assembly, the capacitors C1, C2 and C3 are in parallel combination. Parallel combination with respective capacitances. With respect to capacitances, what is C1? Epsilon naught, area is small a, by separation is B. Okay, this is C1. And C2, epsilon naught, area is A, separation 2B. And C3, epsilon naught, area is A, separation is 3B. And because of parallel combination, and effective or net capacitance, effective capacitance of this assembly C effective will be equal to C1 plus C2 plus C3. From C1, C2 and C3, epsilon naught A by B common factor. Am I correct? Epsilon naught A, small a, by B into 1 plus 1 by 2 plus 1 by 3. Okay. So B, B, B. First separation B, second separation 2B, and third separation 3B. Correct only. Just to simplify, and what is the final answer? I use this space and C effective, and 3 plus and 6 plus 3 plus 2. So 6 plus 11, 11 by 6, 11 by 6. So 11 by 6 of epsilon naught A by B. 11 by 6 of epsilon naught A by B. So this is the final answer. So we'll discuss one more example. It's a very important example. Okay, this is A, this is B, this is C1, is C2, the middle one C3, this is C1, C2. Okay, draw the diagram first. Draw the diagram first. So this assembly or this structure has three different capacitors. The circuit contains three different capacitors. Three different capacitors C1, C2 and C3. Remember student, this is most important. On the left side of C3, the ratio is C1 by C2, correct? Right side of C3, the ratio is C2 by C1. Just the ratio is reversed. Left side is C1 by C2, right side is C2 by C1. The middle one totally different other than C1, C2. So remember student, and this cannot be solved by using balanced Wheatstone bridge. Balanced Wheatstone bridge. Then use this formula. Very important formula. What is effective capacitance? And C1, C2 two times repeated. So 2 times C1, C2 combination, and C1, C3 one time, C1, C3, and C2, C3 also one combination, C2, C3, the denominator, and C1 plus C2 plus 2 times C3. This is a formula. Once you come across this kind of circuit with violation of balanced Wheatstone bridge condition, the left side ratio just reverse of right side ratio. Very very important. Left side ரேஷியோவும் ரைட் சைடு ரேஷியோவையும் மல்டிப்ளை பண்ண என்ன வரணும், 1 வரணும். வெரி இம்பார்ட்டன்ட். C1 by C2 into C2 by C1 ரெண்டு ரேஷியோ மல்டிப்ளை பண்ண என்ன வரணும், 1 வரணும். இதுதான் key point. Ratio on the left side, ratio on the right side, the product 1 na, use the formula 2C1 C2 plus C1 C3 plus C2 C3, so divided by C1 plus C2 plus 2C3, the most important formula. Using this formula, you can get the final answer quickly. So in the next class, we will discuss and problem based on this circuit. Just the formula is given, just we are going to apply the circuit formula alone, then we can get the answer. So we will continue and we will wind up today's session.